Hi guys, hope you're doing well. We're just going to finish up the 5-1 notes that we started on Monday. There's not much left, and we've actually already done this year. It's just coming back now that we're talking about normal curves and standard bell-shaped curves. So this is the empirical rule. We did it earlier in chapter 2. So we're just going to review it really quickly. It's perfectly bell-shaped, which is what we're focusing on. Okay. The mean is in the center, just like we talked about on Monday, that the mean, the median, the mode are all the same in bell-shaped curves, so it's perfectly centered and it's the highest point. The inflection points, which is what we focused on earlier, are one standard deviation away from the mean, so your inflection points would be in those two circled places. Baby sigma still means standard deviation, so to move to the right, you are adding your standard deviation each time. And to move to the left, you are subtracting your standard deviation. So from your mean, you're subtracting a standard deviation. It says the whole and part of the empirical rule is that 99.7% of the data in any kind of normally distributed curve is within 3 standard deviations of the mean. So once you're outside 3 standard deviations, there's hardly any data outside of those places when you have a normally distributed bell-shaped curve. Okay, so the way we use this, just like we did in chapter 2, is you'll be given the mean and the standard deviation. So you'll put the mean in the middle, and then you move your standard deviation, add it 3 times to the right, subtract it 3 times to the left, and then you can answer the questions accordingly based off of that. So this says adult IQ scores are normally distributed, which tells you that you get to have a bell-shaped curve with the mean being 100, so that's your mu, and the standard deviation being 15. So 15 is your baby sigma. Okay. Estimate the probability that a randomly chosen adult has an IQ between 70 and 115. So we have to find between 70 and 115. So we're going to just fill it in. It's way easier if we just fill in the table, the chart, and then answer the question from there. Okay. So your mean is 100. That goes in the middle. Okay. You are adding your standard deviation to move to the right, and it says our standard deviation was 15. So then we go to 115, 130, and 145 because we are adding 15 because that's our baby sigma. Each time you move, you add baby sigma, which is 15. Okay, so we add 15, add 15. To move to the left, you're subtracting 15. So we're going to go from 100 to move to the left takes you to 85. Then you subtract 15 again, and you're at 70. And then you do it one more time, which at the bottom puts you at 55. Okay? Once you have it all filled in, with your mean in the center and your standard deviation added to the right and subtracted to the left, then you can go and answer the question. So between 70 and 115, so here's 70, here's 115, and it asks the probability that it falls between those two pieces. So what we have to do is we have to look at the curve in between those two pieces and just add up the percentages that correspond between those two chunks. So we're going to add 13.5 plus 34 plus 34, which is what I already have written up here. Since they were percentages, I put them into decimals. You don't have to do that. You can just say 13.5 plus 34 plus 34, if that's okay. Either way, we are at, so if we have 13.5 plus 34 plus 34, it gives you 81.5. This says 18.5. It's 81.5. So you have an 81.5% chance that it's going to fall between 70 and 115. Okay? It's pretty simple. This says estimate the probability that a random chosen adult has an IQ between 85 and 145. So same thing. We're using the same set of data. We're just focusing on 2 different numbers from the bottom. Okay? So this time we're going to do 85 and 145. So here's 85, here's 145. So we're going in between those 2 numbers on our curve and adding up all of those percentages. So that's 34 plus 34 plus 13.5 plus 2.4 plus, oh, that was it. The 0.1 doesn't count because that cuts off at the 145. So we're stopping after the 2.4. So you just add them together. So 34 plus 34 plus 13.5 plus 2.4 gives you 83.9. So there's an 83.9% chance that it's going to fall between 85 and 145. Okay. The other thing that we could do, the other way the questions can be asked, is that they can say, instead of giving you the numbers at the bottom, they could give you the percentages instead. So they could say, between which two values will 68% of your data fall? So you say, okay, here's 68% of my data is within one standard deviation, so that's between 85 and 115. So they could give you the percentages or the numbers, and you just have to be able to go both ways. Again, we've done this, but I'm just reviewing. So if they say give you the percentage, you got to look along the top and then find the numbers from there. If they give you the numbers, you start at the bottom and then add the percentages up along that span. Okay? Hopefully that makes sense. Tried to make it fast so you don't have to listen to too much. You should have already done this day 1 assignment. This was due Tuesday at midnight, so that should be done and gone. Okay? You are now doing day 2. So you are doing numbers 9 through 14 and 17 through 20 on that 5-1 worksheet. Okay? Hope everything's going well. Hope you're staying in and staying healthy. I miss you all, and hopefully we can see you guys again soon. All right, bye guys.